All right, what's up, Math 8? Today we're going to start with 1.6, which is scientific notation. As you can see, we're backtracking a little bit in your book. So this is actually towards the beginning of your book, on page 51. All right, so yeah, we will go ahead and get started on it. Scientific notation, excuse me, is basically dealing with tens a lot and then different powers of tens. Okay, it's also dealing with place values and digits and things like that. So we'll just go ahead and jump into it. All right, so the first and the main idea of scientific notation is that scientific notation is where a number is written as a product of a factor and an integer power of 10. Okay. And then the factor is going to be between 1 and 10. All right. So they give us a good example right here of 1. Another example would be like if we're going to do 35, we'll say. The scientific notation of that would be 3.5 times 10 to the power of -1. Okay. And then, yeah, so we'll just go ahead and get into the examples of how we get things like this. I know this by itself without any explanation is probably a little bit confusing, but we'll go ahead and look at it here with these examples. And sorry, I just realized I wrote this wrong. That's 10 to the first power. I don't know why I was thinking to the negative first, but yeah, 3.5 times 10 to the first power. All right, so yeah, now we'll move on to the examples. Sorry about that. All right, so example 1, we have 5.34 times 10 to the 4th power. Okay, so basically all we need to do for that is our exponent is going to tell us how far we're moving our decimal point. Okay, so we have 5.34 here. Okay, whenever the exponent is positive, we're going to go to the right. Okay, and we're going to move it 4 places. So that would be 1, 2, 3, 4. And then those spots in between, we're just putting zeros. Okay, so now we have our decimal point right here instead of here. So that would be 53400.0, which is the same thing as 53,400. Okay, and that would be where we end up on that one. Okay. Before we do example 2, I'm just going to write this down, the definition here, just for you to go ahead and do, or not the definition, but just a little bit of notes for you to go ahead and write in. So when the exponent is positive, you are going to move the decimal to the right. Okay. All right, and that would be this direction, in case we don't remember our rights and lefts. Okay, so that would be if we have a positive exponent. Okay, on the other side of it, if we have a negative exponent, so if the exponent is negative, you will move the decimal. Sorry about that. You'll move the decimal to the left, okay, which would be this direction. All right. All right. Sorry, the bell rang and I had people I was talking to, so I might repeat myself a little bit here. I don't think so, really. I think we just finished the first two examples. If I'm wrong on that, sorry about that. But yeah, so we have exponent is positive. If you move right, exponent is negative. You move the decimal to the left. Okay. And then going the other direction. So it says write each number in scientific notation. So if we look at example 3, we've got 3,725,000, and we need to write this in scientific notation. Okay, so just remember the decimal point is right here because it's right after our ones place. Okay, and then the number needs to be between 1 and 10. Okay, that means we've got to put it so that we have one number in front of the decimal, basically. Okay, and I'll write that over here as well for us. So we want one number in front of the decimal. All right. Okay. So if we go back to example 3 right here. Yeah. All right. Sorry about that. I'm back again. So we want one number in front of the decimal. So basically we're going to move it and we're going to count the number of times we move it. Okay. So we go 1, 2, 3, 4, 5, 6 times. Okay. So we moved it 6 places, and we moved it 6 places to the left. All right. And actually, we're not going to keep track of whether we moved it left or right so much. Whoops. As much as we're going to look at the original number, whether it's greater than or less than 1. Okay, so since the number itself is greater than 1, this tells us that our exponent will be positive. Okay, so we have this number. Okay, so 3.725 times 10 to the 6th power, and the reason it's the 6th power is because we multiplied, or we moved the decimal 6 places. All right. Yeah, that is pretty much it for that. So up here we kind of talked about if the exponent is positive, we go to the right, whereas if it's negative, we go the other way, we'd go left. Okay. Down here it's a little bit different. So if the exponent, or sorry, wrong way. So if the number is greater than 1, we are going to have a positive exponent. And if the number is between 0 and 1, then the exponent is negative. Okay. Yeah. So make sure you get that written down in your notes, and then we'll go ahead and go to example 4, which is the same idea that we were just looking at. So we have the number 0.0000316. All right, and then we're going to look at where we need to move the decimal. So again, we want one number other than 0 in front of the decimal place. Okay, so that means we need to move it right here. All right. So we go 1, 2, 3, 4 in order to get it there. Okay. That means our exponent is going to be 4. Okay. If we look at our original number, it is less than 1. It's between 0 and 1. So that means it needs to be a negative exponent. Okay. So the exponent is negative. All right, so now we have our number 3.16. That's our new number right here. And then we multiply by 10 to the negative 4th power. All right, and again, that 4 came from the number of times we moved our decimal. All right, and that's pretty much all you need to do with scientific notation. That's pretty much all there is to it. Okay, so I want you to go ahead and try out problems D, E, and F on your own. And then once you've done that, we're going to call it for this video. We're going to look at the rest of this probably. I guess not for sure, but some of it we'll probably end up looking at in class. Okay, so yeah, just make sure you've got this stuff down, and then you are good to go for this video lesson. So I will see you guys in class.